Hello. Today we're going to learn about inequalities. We've just finished equations before we took our long 2-week winter break. And now we're coming back with inequalities. And today you're going to learn how to read and write them and to graph them on a number line. This is some vocabulary we're going to be using today. The word inequality, algebraic inequality, solution set, and compound inequality. Alright, so the first definition we want to look at is, and you're going to fill in the blank here, this is your first slide on your handout. An inequality states that two quantities either are not equal or may not be equal. An inequality uses one of the following symbols. Again, it's two quantities either are not equal or may not be equal. And here's our symbol. So this first symbol means is less than. And we could read from left to right just like we do in normal reading. And the words or phrases that sometimes you see with it is fewer than or below. Like below 0. There are going to be fewer than 6 people in class today. The way I like to remember it is that the small side right here, the arrow is pointing towards the smaller number. So whatever this number is, it's going to be less than the number over here, which will be bigger. And so that means this next sign should be greater than, and some common phrases, more than, above. Next one, this little line down here means it could also be equal to. So is less than or equal to, at most, no more than are words that we would interpret as less than or equal to. And then the last one, of course, would be greater than or equal to, and that would go with at least or no less than. And we'll look at these in much greater detail here in just shortly, actually. Write an inequality for each situation. So the first one says there are at least 15 people in the waiting room. So we're looking at how many people are in the waiting room. There's at least. Well, at least means that's the smallest quantity that could be there. There could be 15, or there could be more. So that means the number of people in the waiting room is going to be greater than or equal to 15. 15 is the least it could be. Second one, the tram attendant will allow no more than 60 people on the tram. Will the attendant let 60 people on? Yes. Will they let 61? No. Would they let 61 and a half? Well, if there was a half a person coming on there, I guess I know. I don't know. I'm not even going to go there. But anyway, it can't be any more than 60. It could be 60 or less. So there we would say the number of people is less than or equal to 60. Next one's there are at most 10 gallons of gas in the tank. That means the most it could have is 10. It could have no more than that, so it's got to be less than or equal to. The gallons of gas is less than or equal to 10 gallons. And then there is at least 10 yards of fabric. There might be more. The least there is 10. Can't be any less than that. So it would have to be greater than or equal to 10. So we also want to look at algebraic inequalities. And algebraic, of course, that means they're going to have a variable in them. So a value of the variable that makes the inequality true is a solution of that inequality. So just like when we worked with equations and we would find, when we'd solve it, we'd say x is equal to some number. That's the number that we would plug back in to check to see and make sure it worked. Well, now we're saying there could be more than one. And an inequality, if they can have more than one solution, we say that all those solutions together they're in the solution set. So there would be a set of numbers that would make it true, not just one number like in an equation. And then the last little thing here, you can graph the solution of an inequality on a number line. So a solution set can be actually graphed on a number line. And if the variable is greater than or less than a number, then that number is indicated with an open circle, because that means that number would not be included if it's less than but not equal to. And we'll look at that right here. So in this situation, we're saying that the solutions to our inequality, which we're going to write here in a second, they have to be anything bigger than 5. They can't be equal to 5 because there's an open circle. It can come all the way up to 5, but it cannot include 5. And when you approach 5 there, I know this, we've talked about this before, it approaches it and it can't get to 5 actually, because you could go into infinity and say, 5.000000000000001, but you could keep on going with zeros and then put the 1 behind it, so it gets very, very close to 5. That's why we put the open circle, because it cannot equal 5. So that would be then a is greater than 5. Any of these numbers would be a solution. 5.000000001 is greater than 5, so it would fit in there for A. 7 is one of the solutions in this shaded region, so 7 is greater than 5. 5.9 is greater than 5. Anything that lies on this number line to the right, to the immediate right of 5, is a solution. If the variable is greater than or equal to, or is less than or equal to, then we're going to use a closed circle. So you're going to fill in your blank there with closed. So this one right here shows that B is less than or equal to 3. Yes, it could be equal to 3 because that shaded in saying 3 is included. Now, is 3.1 included? No. Is 3.00000000001 included? No. Because those numbers to the right of, they're immediately to the right of 3, are bigger than 3. But 3, if I plug that in, that works. 3 is less than or equal to 3 because it's equal to. It can either be less than or equal to. Any of these numbers down here, like -2 or -3 or 0 or 2 or 1, those are all less than or equal to 3. 2.99999999999, yep, it's less than 3 or equal to 3. But 3 is included, so we can include 2.9999, but we cannot include 3.000000001. Alrighty, so we're going to graph the inequality. N is less than 3. That's going to be an open circle on 3, and everything less, unless the arrow points to the left. So we shade in everything to the left of 3 in an open circle. Now we've got greater than or equal to 4, all the A's. Anything that we could plug in for A that would be greater than or equal to 4 means going to be to the right of 4 is greater, and you include, I said 4, that's -4, and we include -4. So we're going to put a closed circle on -4 and everything to the right. So please do that on your notes as you go through. Okay, a compound inequality. It's the result of combining two inequalities. So compound goes in your blank, compound inequality, we combine two inequalities. The words and or are used to describe how the two parts are related. So we're going to be looking, because there can be more than one thing happening at a time. So x could be greater than 3, or it could be less than -1. In that case, we're going to have to shade everything greater than 3, and we have to shade everything less than -1. Notice there's no equal signs, so there will be open circles on both. Everything to the right of +3, everything to the left of -1. Well, we're going to graph them one at a time. And if we look over here, here's another one, and this one has an and in it. So we have, you can have or for compound inequalities or and. Here, y is greater than -2. And notice I read that backwards because the variable is backwards. I could say -2 is less than y, or I can say y is greater than or equal to -2. It's easier in algebra to read the variable first. It makes more sense. So we're looking at all y's that are bigger than to the right of -2, but not including -2. And then we're also looking at all the y's that are less than 4. Okay. So compound inequality, we just looked at that one there, and that can be written another way, and you'll notice once we graph it, it'll make more sense to you. But we can say that y is greater than -2 and y is less than 4. So this is read the exact same way as this, but that's not true with or. And you'll look at the graphs next so you can see y, and if you notice, y is between -2 and +4. Can't include either one. Also, I just talked about this, how you can read backwards, that -3 less than b, which I would rather read b is greater than -3. That would be the same as reading it left to right, b is greater than -3. Okay, well, let's look at a graph. Now we're going to look at a compound inequality with or. So we're saying that these solutions can either be less than or equal to -2. So everything, including -2 and everything to the left, or m can also be greater than 1, which means everything to the right of 1 but not including 1. So if we look at these separately, now you don't have to draw two separate graphs. I'll show you what I do to make it a lot easier, but right now we are going to look at two separate graphs. So m is less than or equal to -2. Okay, it's equal to, could be equal to, that's true, so we put a solid circle, or a closed circle on -2, but we want all the m's less than, so we shade everything to the left. Now we could also have m be greater than 1, so that would be an open circle on 1 and everything to the right. Now you notice if we put these two together, there's a gap here, a place where there's nothing shaded in between -2 and +1. +1's not included, -2 is included. So all of this part cannot be a solution. Anything between bigger than -2, less than or equal to 1. We don't have to say that, but that's what's not being shaded. So we're doing what we call an intersection of those two graphs, combine them both to see what the solution would look like. And we put those on the same graph. Now this one, remember, we read it and. B can be greater than -3 and it can also be less than 0. So if we look at those two separately, b greater than -3 means it has to be all b's to the right of -3 because it's saying b's are bigger than -3. So we put an open circle on -3 and everything to the right. And we're also going to do b is less than or equal to 0, which means we'll have a closed circle on 0 and all the things that are to the left are less. Now, our b's have to satisfy both requirements. They have to be bigger than -3 and at the same time less than 0. Okay? So that can only include the stuff that's shaded in. It can include the 0. It's included up here, so it's included down here, so it can be included. Nothing to the right of 0 because it's not included down here. It has to satisfy both. If I come over here, where these two overlap, that's all included, but this open circle, -3 is not included. Even though it's included here, it's not here, so we can't include it. So as we bring these two together and look at them together, and this is how I would graph these, I would just write one number line and I would graph the one inequality above, so that's the open circle and everything to the right of -3, and then I would do the other one right below it, or everything less than 0, and then I can now see better where they overlap, and that's all I'm going to graph. So open circle on -3, closed circle on 0, and shade the overlapping part. I made it purple just so you could see that red and blue together make purple. Alright, so now that is all that's on your paper, but I thought, well, let's look at two more just to help you out here. You don't have to write these down. But now we have w is less than 2 or w is greater than or equal to 4. Notice this is everything to the left of 2, this is everything to the right of 4, so between 2 and 4 there's part that's not included. So let's look and see what's not included. So w is less than 2, is open circle and 2, everything to the left. W greater than or equal to 4, closed circle and 4, everything to the right. Now, we're going to take both of these because it could be here or it could be here. It could be in either place, and it would be a solution. And I'm going to stop here because we're running out.